Today, we're taking a look under the hood of an absolute giant in e-commerce, Shopify. We're going to dive into the specific engineering choices that let them handle a kind of traffic that most companies can only dream about. So, to really wrap your head around what impossible scale actually means, let's start with this number, 173 billion. That's how many requests Shopify's platform handled during its last Black Friday event, in just one day. And that pressure, it doesn't let up. At its peak, the platform was soaking up 284 million requests every single minute. That's not just a quick spike, it's a sustained fire hose of traffic that would absolutely shatter most architectures. Now, here's what's so fascinating. You'd expect some exotic, custom-built tech stack, right? But when you look at the core, you see names you know. Ruby on Rails, React, MySQL, Kafka. It almost looks, well, normal. And that brings us to the big question we're going to answer. How on earth does Shopify take these familiar tools and build a system that can handle some of the biggest shopping events on the planet? Let's break it down, problem by problem. First up, we have to talk about the heart of Shopify's system, its original Ruby on Rails codebase, a monolith. Now, as any platform grows, the monolith often becomes this big, slow bottleneck. It's hard to change, and it's even harder to manage. And Shopify's monolith is, well, it's massive. We're talking about 2.8 million lines of Ruby code. This isn't some dusty old app sitting in a corner. This is the sprawling engine that still runs the core of their entire business. So, they had a huge choice to make. Most companies get to this point and they decide on a massive, risky, multi-year rewrite from scratch. But Shopify, they went the other way. They decided to double down, to invest in their foundation and make it stronger and more scalable from the inside out. So what does that investment look like? Well, they poured resources into making Ruby better for everyone. They built YJIT, a just-in-time compiler that gives them a huge performance boost. They integrated Sorbet, a type checker that helps catch errors before they ever cause problems. And this is the really clever part. They took a feature called Rails engines and used it to create a modular monolith, essentially breaking their huge codebase into smaller, more manageable mini applications that all live together. Okay, so the application code is getting more manageable, but what about the data? With millions of merchants, having a single giant MySQL database is just a recipe for a massive failure. Their first move, way back in 2014, was a classic scaling strategy: database sharding. The idea here is pretty simple. Instead of one huge database, you split it into a bunch of smaller, faster ones called shards. For e-commerce, this is perfect. You can stick different groups of merchants on different shards, because one store's data doesn't really need to talk to another's. But sharding was just the beginning. Shopify took this idea and pushed it so much further. They evolved from that single database to the sharded model, and finally to this concept they call pods. A pod isn't just a database shard. It's a totally self-contained, isolated slice of Shopify's entire infrastructure. It's got its own MySQL, its own Redis, its own Memcached cluster, the whole shebang. And here is why this is such a game changer for staying online. Before pods, if a single shared component, like a Redis cache, had a problem, it could create a domino effect and crash the entire platform. But with pods, any failure is contained. An issue in one pod just stays in that pod, and the rest of the platform keeps humming along. It's like building a ship with watertight compartments. Okay, so we've got a modular monolith and these super resilient, isolated pods. But how do you get all these hundreds of different services and components talking to each other reliably, especially when you're processing millions of events every second? Their philosophy is all about asynchronous communication. And this quote from their engineering team captures the idea perfectly. Instead of services directly calling each other and waiting around for a response, they just publish events to a central stream. Producers, like an order service, just fire off an event and move on. Consumers, like a shipping notification service, pick it up whenever they're ready. It completely decouples the system and builds in so much resilience. The backbone for this whole asynchronous system is Apache Kafka, and it's operating at a scale that is just mind-blowing. At its peak, Shopify's Kafka cluster is processing 66 million messages per second. It's basically the central nervous system for the entire platform. Now, of course, not everything can be asynchronous. For those direct, real-time communications, they just use the right tool for the job. Some older services might still use Rest, and that's fine. But for all their modern, public-facing apps, like the web admin and mobile clients, GraphQL is the standard. It's fantastic because it lets them get exactly the data they need in one go. And for all that super fast internal chatter between services, they're moving to gRPC. So we have a scalable monolith, we have resilient databases, and a really robust way for them to communicate. The last piece of the puzzle is the human one. How do you let hundreds of developers ship code to this critical system every single day without, breaking everything?
Well, their first line of defense is just an absolute mountain of automated tests. Every single change that gets proposed for the core monolith has to pass a run of over 400,000 unit tests. It's a massive safety net that catches problems long before they ever get close to production.
They've also built and even open-sourced an amazing suite of tools for what they call resilience engineering. Packwork makes sure their modular monolith actually stays modular. ToxyProxy lets them deliberately create network failures in testing so they can see how their code reacts to chaos. And Semyon is a circuit breaker that stops one failing service from taking down others in a chain reaction. Now, this might be one of the most surprising parts of their whole strategy. They don't use staging environments. Why? Because a staging environment can never truly replicate the chaos of real-world production. Instead, they deploy straight to production, but in a very controlled way. They use canary releases to test new code on just a tiny fraction of users, and they use feature flags so they can instantly turn off anything that starts to look fishy. So when you put all of these pieces together, the monolith investment, the pods, the communication patterns, the developer tooling, a really clear engineering philosophy starts to show up. And it's not about chasing the trendiest new technology. It's about something much more fundamental. You can really distill it all down to 3 core principles. First, master your tools. Shopify didn't ditch Ruby on Rails. They invested like crazy to make it one of the most performant and scalable platforms out there. Second, isolate failure domains. The entire pod architecture is built on containing the blast radius when things go wrong. And third, empower your developers. Give them fast feedback, automated safety nets, and the tools they need to move fast without breaking things. This whole approach leaves us with a final thought. For decades, the default answer for a big, aging system was the big rewrite. But Shopify is showing us a powerful alternative. Invest in what you have, but isolate everything. And it really makes you wonder, is this invest and isolate model the new blueprint for engineering at massive scale?